Welcome to the DIY Honda Garage channel. The DTC P055B, indicating a rocker arm oil pressure sensor out of range, specifically relates to the oil pressure system that aids in the engine's performance. The rocker arm oil pressure sensor's primary role is to ensure that the correct amount of oil pressure is supplied to the rocker arms, which are responsible for opening and closing the engine's valves. Located near the engine, the sensor communicates with the powertrain control module, PCM, to monitor oil pressure levels. If the pressure falls below a specified threshold, the PCM will trigger the warning light and log the DTC. Understanding this error code is crucial for maintaining optimal engine function and preventing severe engine damage. Correct diagnostics and repairs are essential to restore proper operation of the rocker arm oil pressure system. The DTC P055B signifies that the rocker arm oil pressure sensor is reporting an out-of-range condition. This sensor is integral to the engine's hydraulic system, ensuring that appropriate oil pressure reaches the rocker arms, crucial to valve operation. It is located in close proximity to the engine's valve train assembly, allowing it to provide real-time oil pressure readings to the powertrain control module, PCM. If the sensor fails or the oil pressure deviates from standard levels, it can trigger the DTC, leading to poor engine performance, reduced fuel efficiency, and potential engine damage. The PCM utilizes the signals from this sensor to optimize fuel injection and ignition timing for smoother engine operation. Several factors could lead to the triggering of DTC P055B. One common cause is poor connections or loose terminals at the rocker arm oil pressure sensor, or the PCM, which can interrupt the signal transmission. A faulty rocker arm oil pressure sensor itself is another possibility, where internal defects prevent it from accurately reporting oil pressure levels. Additionally, issues such as open or shorted wires in the VCC2 or P-oil circuits can also result in poor sensor communication and lead to this error. Each of these causes needs to be systematically checked to ensure the reliability of the oil pressure readings and overall engine performance. When DTC P055B is present, the most obvious symptom is the activation of the check engine light, alerting the driver to a potential issue with the vehicle's engine management system. Other symptoms may include noticeable poor engine performance, which can manifest as sluggish acceleration or irregular idle speeds, primarily due to incorrect valve timings. Increased oil consumption might also be observed, indicating improper oil pressure affecting the lubrication of the engine's moving parts. Drivers might notice warning signs such as unusual noises from the engine, which could be a result of inadequate lubrication. Addressing these symptoms in a timely manner is crucial in preventing further engine complications. For the first troubleshooting step, begin by turning the vehicle to the on mode, activating the electrical systems without necessarily starting the engine. Utilize the Honda Diagnostics System, HDS, to examine parameters related to the rocker arm oil pressure sensor. It's essential to check the oil pressure sensor's voltage. It should ideally be above 0.27 volts. If the current conditions meet the specified threshold, the failure appears consistent, allowing you to proceed to the next step. Conversely, if the current state does not match, this suggests sporadic issues, requiring you to inspect for poor connections or loose terminals at both the rocker arm oil pressure sensor and the PCM. The second troubleshooting step involves turning the vehicle to the off mode to ensure safety while handling components. Disconnect the 3P connector from the rocker arm oil pressure sensor, which allows for further testing without interference from other components. Next, turn the vehicle back to the on mode and again access the HDS to measure the voltage of the rocker arm oil pressure sensor. The expected voltage reading should be 0.27 volts or lower. If these readings align with the specifications, you can confirm an issue in the next stages of testing. However, if conditions vary, follow subsequent steps to assess the sensor's integrity and wiring. During the third troubleshooting step, the objective is to measure the voltage across the rocker arm oil pressure sensor's test points. With the connector still disconnected, use a multimeter to measure from test points 1 and 2. Under conditions where the vehicle remains in the on mode, the anticipated voltage reading should be approximately 5.0 volts. If the reading matches this value, it indicates the sensor's failure. Hence, you will need to replace the rocker arm oil pressure sensor to restore function. On the other hand, if the reading does not align with expectations, move to the next troubleshooting step to examine potential wiring issues. The fourth troubleshooting step focuses on checking the integrity of the VCC2 wire, which provides necessary voltage to the sensor. Start by turning off the vehicle and executing ASCS, SRS short, using the HDS, allowing more than a minute for the system to stabilize. Next, disconnect the PCM connector E, 80P, to isolate potential issues in the circuit paths. With the rocker arm oil pressure sensor 3P connector disconnected, examine continuity between the test points at the sensor and at the PCM connector. If there is continuous connectivity, this confirms that the VCC2 wire is intact, and you can proceed to further diagnostics or check related service information. If not, it signifies an open wire, necessitating repair to ensure proper function. In the fifth and final troubleshooting step, you will need to assess the P-oil wire for any short circuits. As before, begin by turning off the vehicle and performing an SCS jump using the HDS for stabilization. Following that, disconnect the PCM connector E80P for isolation, while ensuring that the rocker arm oil pressure sensor connector remains disconnected. Test continuity between the sensor test points and the body ground. If continuity exists, this denotes a short within the wire between the PCM and the rocker arm oil pressure sensor. If continuity is absent, it suggests the wire is in good condition, prompting a review of authorized service information, or considering substitution with a known good PCM. After repairs associated with DTC P055B have been conducted, it is critical to complete a final verification process to ensure proper operation. Begin by double-checking all electrical connections to guarantee that they are secure and corrosion-free, which prevents new issues from arising. Clear any diagnostic trouble codes, DTCs, from the ECU, and conduct a test drive to observe if the system functions correctly under real driving conditions. Monitor the performance of the rocker arm oil pressure sensor closely to verify that it reports appropriate oil pressure levels without triggering any new DTCs. Successful completion of these verification steps confirms that the original issue has been resolved, allowing the vehicle to operate reliably. To prevent future occurrences of DTC P055B, implementing a solid preventive maintenance regimen is essential for the vehicle. Regularly checking the oil level ensures that the engine has adequate lubrication, which is critical for maintaining proper oil pressure. Performing timely oil changes according to the manufacturer's recommendations not only improves engine performance, but also extends the lifespan of the rocker arm oil pressure sensor. Additionally, routinely inspecting engine sensors, including the rocker arm oil pressure sensor, can catch potential failures before they cause significant issues. Creating and adhering to a maintenance schedule will ultimately contribute to the longevity and reliability of the vehicle. In conclusion, understanding DTC P055B related to the rocker arm oil pressure sensor out of range is vital for effective diagnostics and repairs. Identifying the issue and systematically following the troubleshooting steps helps pinpoint the root cause of the sensor failure, whether it be a faulty sensor, poor connections, or wiring issues. Completing thorough repairs and conducting final verification ensures that the vehicle operates efficiently, while preventive maintenance minimizes the risk of future problems. By committing to diligent maintenance practices, vehicle owners can enhance both engine performance and longevity. Properly addressing DTCs not only enhances reliability, but also contributes to overall vehicle safety. Please like and subscribe to the channel. See you next time.